Hi everyone, this is a quick overview of Tekla structures and the integration to the Qnect connection design software. Qnect is an engineering software for the design of connections passed from the Tekla model. Quite simply, we build a frame within Tekla, just point-to-point members, apply the loads, we then export that, it's then passed to the Qnect cloud where the data from the model is analyzed, and then the connections are passed back to the Tekla model, fully connected and designed as per the specifications and requirements. So a little overview here, you can see it. So what we do is we build up a Tekla model, as you can see like in the bottom left hand corner. We upload the Tekla data. This is not the model that's uploaded, it's just the data from the Tekla model. It's taken to the Qnect cloud service, where the data is analyzed, the applicable connections are applied and designed as per any loads, and then they're passed back to the Tekla model. So the Tekla model is then complete with all the connections, including all the design calcs to back it up. Okay, so how do we start with Qnect and Tekla? First thing we do is just register with Qnect and create an account, download and install the Tekla plugins, which then can be seen within the Tekla model, and then you're ready to start doing connection design. Okay, so how do we create an account? You can see here's a small video. So what I do is just type in my name, company, etc. just on the Qnect website itself. You can see the web address at the top, qnect.com. Sign in, create a password. Once you've created your account, sign in the actual account itself. Once you're within then what we call the Qnect dashboard, you can then download the Tekla APIs, which allow you then to connect the Tekla model to the Qnect software. So we've downloaded those, we then install them, and then you can see within Tekla, which of course is Tekla 2016 I'm showing here, quite simply type in Qnect in the components catalog and you can see the applicable Qnect components to use. Quite simple. Okay, then once that's done, we then set up a project in Qnect. So in Qnect again, what we do is we sign in. There's a list of sort of sample jobs available here. I'm just going to create one my own, which is Tekla example, and then what we do is we set up that project to our own fabricators requirements or engineers requirements. So quite simply, what kind of package are you looking for? Just engineering, including revision control. And then we can say, okay, what type of connections? So for beam to beam shear, we've got then the order of the connections of preference, and again just fill in the bolt preferences. Are they staggered, non-staggered? What size, what's my preferred size of bolts? What's my preferred weld size? So on and so forth. So type of connections preferred, type of bolts, type of welds, and that's the project then completed. Quite nice and simple to do. So again, let's just take a look at that. What we do is we create a project in the Qnect dashboard, save that away, then we're ready to start creating our job from the Tekla model to the Qnect software. Okay, so let's take a look at that. So here we have a Tekla model. You can see here it's just beam to beam, point to point, actually drawn in. I have actually applied end loads to the end of these members, as we would with any kind of typical end load. What we do then is use the option 1, which is Qnect export, give it a project name, submit that. It then writes the data out and passes it to the Qnect cloud, where it's then analyzed for the connections, engineered connections. When it's done, you will receive an email back telling it's completed. Then we're able to go to the next step, which is to re-import them. Okay, so what we do is then we select part or all of the Tekla model, upload it to the Qnect cloud service, receive the email confirming it's been engineered. Again, you get an example of the email that's going to come back to you. So Qnect has successfully engineered 66 connections for this particular project. Okay, then we bring those connections back into the Tekla model. So again, here's a Tekla model. We use option 2, import back in the same project we just exported, submit that, and then you can see then the engineered connections are imported back into the Tekla model. And if we take a quick walk around there, you can see the connections designed to our preferences. So if you prefer shear tabs first, it's going to use shear tabs or double angles, whatever your preferences are. So that model has been connected and designed, connection designed to our standards and preferences. We can inspect each connection individually. So you can see using option 3 just to inspect all the connections. So quite simply walk through the connections and check that they're correct and the type you're looking for. These are categorized into their different types as well. Again, nice and easy to do. Okay, now another little example here. So clicking on there, you can see the engineered connections, engineered design connections. Just quickly view through. We can view the design calculations, and how we do that is, again, we've got the same Tekla model here. All we quite simply do is double click on one of the connections and that opens up the design calculation. All the standards and options within there, so you can view what they all actually mean and what they're referring to. But you can click on each hyperlink and see what the design calcs and codes are and what it actually means, and scroll through them. Of course, these can be printed out anytime as well. Okay, what happens if there are revisions in the model? How does Qnect handle that? Obviously there are always revisions. So what happens then if we change a member size in the Tekla model once it's had the connection design applied? Then the Qnect listener actually recognizes there are changes to the model. It sends the data back to the Qnect cloud, and then the connections are redesigned or re-engineered as per the new member sizes. Again, let's take a quick look at that. So here we are. This model's already been designed. You can see here we've made some changes. The listener pops up, recognizes some changes, and then re-engineers the connections to suit the new sizes. One final little option in here, which is one of the most important options, is the bolt optimization option. When you're setting up the project, you can see then you can also tick a box which says include bolt optimization. What this does, rather than use the standard spacings between bolts of, let's say, 3 inches, it optimizes those or increases those to actually put less bolts in, but still to be a good engineered connection that works. So you can see here what it does is, if we've got 3-inch spacings, what it does is it increases those spacings, goes down the number of bolts required, but both joints satisfy the same engineering requirements, but with less bolts and less fabrication costs. Same with the welds. So we can run that whole project, get our preferred connections, optimize the bolts to really make sure that we optimize the whole job for the best kind of connection design we can get with lowest fabrication costs. So thank you. A very quick look through there. There is also a full video explaining this, so I'd recommend you take a look at that next.